Question from Kogila. Related your assignment. Kogila Kumar, you excited nak buat assignment? Okay, your assignment. Your assignment, I will give your assignment after test 1. Whatever we will do test 1 first, then after that we will talk about assignment. Okay, Kogila. Ani Zulaika, don't worry, be happy. Okay, question from Nadurul Ain. Your final exam is online or face-to-face? Latest news, your final exam will be do online. Means online, but in the fixed time. I mean, maybe 1.5 hours. Okay, Fatin, ada apa Fatin? Question from Anim. When your test 1 once finish at least chapter 2. Once we finish chapter 2, maybe plus minus with chapter 3, or maybe only chapter 1 and chapter 2, then we will talk about your test 1. Yeah, yes, Kogila, you have final exam, because this is latest news from UM admin. Okay, I think everybody already scanned your attendance. Rian, please scan your attendance. Okay. Okay, today we will move chapter, new chapter, chapter 2. We will talk about logic. Okay. Anything before we start? Class, anything? Okay, thank you Maaz, thank you Anim, thank you everybody. Okay. We finished already chapter 1. Now we move to, today we'll talk about chapter 2. We'll talk about logic. Okay, before we move detail about logic, I need to explain just a little bit about what is proposition, what is logical operation. Okay. Proposition means, in a simple word, proposition means something like sentence or statement. In this we call proposition. In human understanding, we call statement. But proposition is a specific statement. It talk about true and false statement. Later we explain what means by true and false statement. Okay, that's proposition. Logical operation means we talk about the operator, based on the operator. For example, previously once we deal with maths, for example, 2 plus 3 equal to 5. Okay, this kind of representation we call operation. This is the operation. But in logic, we do not utilize this kind of symbol of operation. We utilize another symbol or another situation like this symbol. This symbol means or, represent or. This symbol represent and. And we also utilize this symbol equal, this symbol equivalent. All of this kind is logical operation. So maybe we have S1 or S2. So what happened? What is the conclusion of this operation. So we will this kind of representation. So again, once we talk about proposition, we talk about statements. The statement represent this kind of statement, S1, S2. But this statement constrained on logic statement, true or false. Later I will show to you what is the kind of proposition involved in logic. Then this proposition we will deal with logical operation. So today we will talk about proposition and logical. It means we talk about this kind of representation and this kind of operation. Means this one. Okay, that's the basic idea what we deal about today. Okay, now we move to the first slide. Logic. Once we talk about logic, logic means we deal with method of reasoning. So, method of reasoning. First, we need to know what is method, what is reasoning. Okay, method of reasoning actually the output, the argument of this one is argument we need to find is valid or not valid. Valid or not valid. Okay. So in order to find valid or not valid, we deal with true or false. So again, in order to find the situation is valid or not valid, we deal with true, false. So how we deal with true, false? We utilize method of reasoning. So today, first idea, we need to know what is method of reasoning. Okay, one thing is method, the second thing is reasoning. Method means process, step by step. It means for example, from 1, then followed by 2, followed by 3, and so on. So this step, the process of this step, we need to know. So in order to find first step, followed by second step, followed by third step, we look on is that true or false? True or false? That's the idea behind method of reasoning. So from one statement to another statement, followed by the third statement, and so on, we look on true or false, true or false, true or false. Then the ending of this statement, the conclusion, we can call valid or not valid. So this process from here to here, we call reasoning. So in a simple word, method of reasoning, we deal with statement through enforce situation in order to find valid or do not valid. So that method of reasoning. Okay, then proposition. Proposition is statement in human understanding. We call statement. Statement something that we talk about, but specific on proposition is a statement, but declarative statement. It's not about the other statement. We focus on declarative sentence. Declarative sentence, we focus on true or false, but not both. For example, I said here, the earth is round. This is a statement and declare the earth is round. Everybody know. Yes. The answer, yes. Okay. Sometimes some people say no. But the important thing is the ending, the answer is yes or no. True or false. Okay. 2 plus 3 equal to 5. In logic, in maths logic, this is true. This is true. This is true. But the other statement, once we deal with which one is blue, see, they have question mark. It means this is not a statement. This is a question. Okay. The sun will come out tomorrow. Yes, this is statement, but it still need to prove because we not sure. Even though everybody say yes, tomorrow, but tomorrow is not the present situation, so need to prove. So I will pass this course. Yes, also need to prove it. So whatever come with will, some this statement or this sentence have we need to prove. Be silent. Be silent. This is a not statement. This is a command. So please justify which one is statement, which one not a statement. Once we deal that one is statement, we need to identify that statement is declarative or not declarative. Logic deal with the declarative statement only. So I'm trying to visualize. The idea is one, we have this is the domain of the human said. One of the subset of this statement is a statement. Okay. Beside the others, maybe here command, maybe here question, and some sort with the others. But subset of this domain is statement. But in statement, they have one type of statement we call declarative statement. So this declarative statement actually deal with logic. So see, so the idea of logic, we focus on declarative statement only. That's why in daily routine, human daily routine, sometimes we do not deal with logic. We deal with the other situation. That's why sometimes we think that one is that logic or not. Logic deal with declarative statement. Make sure that statement is declarative statement, where the statement, the based on the statement, we can respond either false or true. Once the response is yes, false or true, we deal with logic. So that's actually the meaning of logic, not based on human understanding. This is the exactly understanding about logic. It means once we deal with logic, we deal just a little bit of this environment, not the whole day deal with the logic. Clear? Class, okay, clear? So don't think everything is logic. No, no. In order to find is that logic or no, try to get the answer from that statement, false or true. Okay, the other statement look like logic, the answer will be yes or no. The answer yes or no not deal with logic, it deal with ethic. Ethic. Okay, they have another statement here out of logic. We call here ethic statement. For example, which like ethic, we must be kind to the other person. That's deal with ethic. But some race will not talk about this thing. The answer will be yes, will be no. It depends to what you believe. This ethic deal with your belief. Your belief. Logic deal with exactly with the facts. Test by science. So logic, we talk about the facts. Ethic, we talk about belief. The answer yes or no. Logic, the answer false or true. See, they have differences between belief and facts. Belief on ethic, yes or no. Depend. The answer may be yes, the answer may be no. Depend on who you are. Logic, universal. Test by science, that's universal. Universal understanding. Like this one. 2 plus 3 equal to 5. Everybody in this world who learn maths will say true. So, but once we look from active view, we can say maybe yes, maybe no, depend. So, discrete deal with the logic, this kind of statement, not about these things. Clear? That's the important thing you must understand related to the logic. That's why once we deal with logic, actually we do not deal with your heart. Okay, now we talk about logical connective. Logical connective means whatever we utilize in logic statement and compound statement. See the word compound statement. Okay, now a question, a command, or a proof are usually not statement or proposition. See, please to understand this statement, not a statement of proposition, question, command, or proof, something need to prove. In maths, okay, in maths, x, y, z we utilize as a variable that we replace with real number. For example, x equal to 5, y equal to x plus 3. This kind of representation usually we utilize in maths. But and then once we deal with the operation, we deal with plus, multiply, minus, and divide. For example, here. Okay, that's for maths. But in logic, normally the variable that we utilize in order to represent propositional variable, see the word propositional variable. This variable we talk about related to statement. Propositional variables, we deal with P, Q, R in order to differentiate between maths and logic. So we can replace propositional statement with a statement, the declarative statement. So once we deal in a discrete or logic, we utilize the variable P, Q, R. Sometimes we utilize S. We do not utilize S, Y. Sometimes we utilize S, Y, Z, but in the standard variable in logic, we utilize P, Q, R, sometimes S. Okay, for example, statement. But now we talk about compound statement. Compound statement means we have P, Q. Two statements here. It is raining today. We represent by P. So this symbol means represent. So P represent it is raining today. Q represent it is cool. So what is compound statement? Compound statement means the combination of at least two statements involved. For example, here P and Q. Utilize logical operation and. So P and Q, so once we write in human understanding, it is raining today and it is cool. So in discrete or in logic, we just represent like this one. We write this declarative, means the statement, representation, then we just represent through P and Q. So P and Q, in human understanding, it is raining today and it is cool. So in discrete or in logic, we just represent through this simple representation. Okay, now we move to another what we call another statement, but we utilize another logical operation. Okay, first we utilize compound statement, we utilize and. Now we utilize the second idea called negation. Negation stem from negative proposition, and combined it called negation. Negation means negation of P. So how we represent negation? So if we have a statement P, so our proposition represented by P, so the negative proposition or negation we put here this symbol, not P. So this represents a negative proposition, negation. Okay, so it is not the case that P. So not P. So truth table for negation, if P true, not P false. If P false, not P true. So this is truth table for negation. Okay, example. Given to you, give the negation of the following statements. So given to P represent 1 plus 2, 1 plus 2 less than 4. So what is the negation proposition? So not P. So we focus on this. This is the logical operation. This is a math. So we just represent 1 plus 2. This is standard. So we look on this symbol. Less than will be greater than equal. Oh, that's negation. So this is true math. How about true statement? It is cool. So not Q represent as it is cool, but we add not here. So it is not cool. So that's the idea behind of the compound statement representation. Okay, then we move to the another idea, the third, we call conjunction. Conjunction in human understanding is is and. Conjunction and. So in discrete or logic we call conjunction. If P and Q are statements, at least we have two statements. P and Q are statements. The conjunction of P and Q is the compound statement P and Q we represent as P not P and Q. So we utilize this symbol with this statement with this symbol. So P and Q. So what is the situation P and Q? The situation P and Q will be true when both. So and if both true, so this statement will be true. Otherwise, false. So what is the situation? We look on the truth table later. Oh, sorry. Okay. Okay, another example. Based on the statement P and Q, so we try to utilize this statement. Okay. P, it is raining. Q, I am cool. The second example, today is Sunday. P, Q, 5 less than negative, 5 greater than negative 5. So based on the P and Q, so it is raining, then I am cool. So the second statement, P and Q, today is sun and 5 greater than negative 5. Okay, this is logic. In logic, you must remember, in logic, we talk about the rules. We do not talk about the meaning of the statement, the output of the meaning of the statement. It means today is Sunday and 5 greater than negative 5. Okay, this is a logic statement. But don't ask, what is the relation between Sunday and 5 greater than negative 5? There's no relation. In logic, that one doesn't matter. The important thing is who put the rules. Once you put like this one, today is Sunday and 5 greater than negative 5. That's true because of this statement. So what is the relationship? Is logic on what is the means between Sunday and this number? What is the relation? Doesn't matter. Look like they have a relation. It's raining, I am cool. Look like have a relation, but actually this is the combination of two statements based on the rules. Okay. Yashini, thank you. Conjunction is true, false, true, false, false. Okay. This is the conjunction truth table or TT. See? True, false, true, false, 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 false. This, you must memorize this truth table once we deal with the conjunction, negation. Another one is disjunction. Okay, conjunction we talk about and then they have another logical operation we call disjunction. Disjunction actually in human understanding is or, and we represent in discrete or logic we represent by this symbol or. For example, P or Q. So what is the situation of P or Q? This statement is true either. See, either. Either means either one. Either P or Q is true. Either P true or Q true. The answer will be true. It is false if both are false. So false only both are false. Okay, for example here, you utilize the same idea is raining, I am cool. So we put here or. We utilize today is Sunday, 1 plus 1 equal to 2. We put just put or. So this is true table. See, true, true, true. True, false, true. Even here false, the answer will be true. Even here false, the answer will be true. But if both are false, the answer must be false. Okay, this one I think simple, you know already. Okay. Now, if that statement more than two statements, even though the statement, the first or second statement repeated, then we represent by S. S means more than two statement representation, or to represent a few statements in one sentence. Okay, for example here, a compound statement maybe have many component part statements represented by propositional variables. So for example, P or put this bracket Q and P or R. Then if more than two, we put represent as S. Then how many condition will be happen if based how many variable involved? For example here, P, Q, and R means three variable involved. Based on the rules, 2n. So 2n, if n equal to 3, here n equal to 3, the answer will be 2, 3, 8. So there will be 8 condition will be happen based on how many variable involved. That's why here P, Q, R. So 2 power of 3, it means 2 power m, 2 power of n. This is a standard representation. Okay. So 2 power of n possible row and this one, okay. For example here, example 5. Make a truth table for statement. We have P and Q. Then this P and Q, we deal with not P, with or. So how we get the answer? First step, we find P and PQ. So we start with PQ. So PQ, we put true, 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 false, false, true, false, false. This is standard. This standard rows. Then P and Q. P and Q, the answer will be true, false, false, false. Here P and Q. Now finish about P and Q. Now we look on not P first. Not P. P and Q, this column. Then followed by not P. So not P, we refer to P. Here true, here must be false. Here true must be false. False, false, true, true. So we get the fourth column for not P. Now we combine this column and this column. What is the logical operation? The logical operation is OR. So we look on this column and this column in order to get the next answer. The connection, the logical operation is OR. So true or false must be true. False and false, for sure false. False, true, because OR, true. False, true, because OR, true. So this is the complete table in order to represent this statement. Okay. So the simple question later in test or in final exam look like this kind of question, but this one is too simple. Okay, finish. Finish about 2.1. Now we move to 2.2. 2.2, we deal with statement, but we deal with conditional statement. Okay, class, can you see this slide? Second slide, 2.2. Okay, good. We still talk about statement, but previously we talked about compound statement. Compound statement, we deal with P, Q. Okay, we deal with the negation. We deal with conjunction. We deal with disjunction. Another one we deal with disjunction, conjunction. Yes, this one. So now, once come to conditional statement, we deal with another type of statement. We deal with first, if, and then. So conditional statement, under this conditional statement, we deal with if then. If P, here P, then Q. So this conditional, if P, what happened to Q? So how we represent in discrete, in logic, we represent through this symbol. So if equal to P, then Q. So there are two symbols here and here. So we combine, it will be if P, then Q. So this we call conditional statement or implication. So once we deal with this kind of statement, conditional statement, we can say that P is hypothesis and Q is conclusion or antecedent or consequence. So if P then Q, we represent by this symbol. So we deal with hypothesis and conclusion. This is hypothesis, this is a conclusion. Okay. Look on the example for conditional statement. So write the application of conditional statement if P then Q for the following statement. P, I am sleepy. Q, I will sleep. P is raining. Q 1 plus 3 equal to 4. So the solution, if I am sleeping, then I will sleep. So this is Q. This is P. So if P, then Q. So we write the statement, if P, then Q. If I am sleepy, then I will sleep. So the second, if it is raining, then 1 plus 3 equal to 4. See, what is the relation raining and 4? Doesn't matter. In logic, doesn't matter. As long as you fulfill the conditional based on the logic rules, this statement will be happen. Okay. Okay. Then once deal with if P then Q, in logic, what means in logic? So in logic, it say that is true insists if P is true, then Q will also be true. So this Q followed by P is true will also be true. Another idea is it means we will not have P true and Q false. This quite confused, but we just ignore this one. Important thing is do not say P cos Q. It say if P is true, then will also be true and not P cos Q. Okay, this one if you look, something that's, this one happened already. This one, not yet. See, not yet. So please focus on this. It is true. If P true, then if Q will be also true. So If false, see, if false only if P is true and Q is false. See, this statement is true, will also be true. But the answer will be false if true, then followed by this one is false. So the answer is false. Okay. Don't confuse with this kind of statement. But the important thing is you pick with this idea and you look on. It is false if and Q is true. This true, this false, so will be false. Okay, what is the truth table for this statement? So truth table said true true will be true. So see, true false. Then Q false, the answer will be false. However, if P false, suddenly here true, it will be true. So depend on Q. So false false, it will be true. This is false, for sure the answer will be true. So this will confuse you later. I will show to you the example. So see the implication. If 2 plus 2 equal to 5, then I am the king of England. So this two statement is true. Why? This statement false. Is that I am a king of England? False. Yes, correct. Because this one false, 2 plus 2 actually equal to 4. But here equal to 5. Then I am the king of England. Yes, correct. Because here false, for sure here false. So this situation true, like this one. Negative, negative, the answer will be positive. Negative times negative, the answer will be positive. That's the kind of the idea in order to represent this situation. Okay. This one is not sufficient. Okay. Another compound statement. Another conditional statement. It talk about converse and contrapositive. This one, please do not confuse with the situation. Converse means we just change the place. Converse of P, if P then Q, actually is if Q then P. Contrapositive, we take out this answer and we put negative in front of this method. It will be contrapositive. See? Okay. Converse, we change the place. We change the place of the statement. But contrapositive, based on the changes, we put negative, negative. So that's the clue how to differentiate between converse and contrapositive of the conditional statement. Example. So we give the converse on contrapositive, converse and contrapositive of the implication. If it is raining, then I get wet. So here P, here Q. So converse, we change the place. Means it is raining, will be here. I get wet, will be here. If then sustain. So converse for if it is raining, then I get wet will be I get wet, then it is raining. That's converse. So contrapositive, we look on this answer, we just put not. See? If here I get wet, so if I do not get wet, here then it is raining, then it is not raining. Put not here, do not here. So that's the clue how we deal with converse and contrapositive. Clear? Okay, class. Hanim, get the idea? Ibrahim, do you get the idea? Yes, good, Ibrahim. Good. Okay, now we move to another situation in conditional statement. We call equivalent. Equivalent, previously I showed to you this symbol. This equal, equivalent here. They have 3 stroke. Equal, 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 only 2. Equivalent, there are 3 stroke here. Or we call biconditional. Biconditional in another question means two-way. From here we have A, we have B. A to B, B to A. So biconditional each other. In other situation, situation means in human understanding, it means together to get her. When both have the same idea. So if P and Q are statement, equivalent or biconditional is the compound statement. P if and only if. So we represent in this script we call if and only if. So we represent by this symbol where if P, so it okay. So we combine these two statements, it will be like this one. So if P then Q, then if Q then P, so actually it's equivalent. So that's why we put these two symbols. If P, if and only if Q. So it will be P is necessary and sufficient for Q. It means both. For example, in a human situation, we have a couple, girls and boy. If and only if mean they love each other. P love Q, Q love P. And they have the same feeling. They have the same chemistry. So in this script we call equivalent. Okay. So once we deal with if and a P, if and only if Q, we look on this statement. If both have the each other, here true, here true, here false, here true, the answer will be both true. So either one will be false. It must be have the same value. So the answer will be true. If either one, for sure will be false. That's the way we represent truth table. Okay. So truth table easy to understand. Truth table for P if and only if Q equivalent means make sure both are have a same value. The answer will be true. If either one, the answer will be false. That's truth table for equivalent. For example, is the equivalent P greater than 2 if and only if Q 0 less than 3 minus 1 is a true. So we look. This one, P greater than 2, yes, true. So 0 less than 3 minus 1. The answer will here 0 less than 1. Yes, true. So the answer will be true. We check here and we check here. Because of n, true, and here true and true, the answer will be true. Okay. Now we look on the truth table through the statement. Okay, given to you this conditional statement related to P and Q. So we have one first conditional. If P then Q. Second, if not P Q, then not P. Second statement. The third statement, the whole thing. Okay, first we solve this part first. If P then Q, so we put here standard PQ, true, 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 false, false, true, false, false. Then if P then Q, we look on this second column. The answer will be true because this truth table represent if P then Q. Then we look on the second statement. Before we deal with both, we look on Q, not Q. So not Q, we look on Q. Here true, here false. false, true, true, false, false, true. So we get the third column. The fourth column we look on not P, so here. True, here must be false. Here true, false, 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 true, true. Now we get 4 column. Now we deal with the exactly here. Not Q, if not Q, then not P. So we look on these 2 columns. So false, then false will be true. True, false, false. False, true, 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 false. This third column and fourth column will look on if then. So the answer based on the situation, based on if then table, we get true, false, true, false, true, true. Now we'll focus on this representation and this representation. We compare. So this column and this column. We look. True, true, for sure true. False, false, true, because both have the same feeling, same situation. True, 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 false, false, true, 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 true. Okay, then the final column means the answer for this statement all will be true, 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 true. So we represent as S. It means here S represent the whole statement. So once we have all true, 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 true. So in logic, there are 3 situations. Means for S, the last for S, if all true and always true, we call this statement is tautology. So it means for any condition, for the answer, all always true. So tautology. But here sometimes suddenly here they have false. So if the situation the whole answer may be true or may be false, we call this situation we call contingency. Contingency. But if all false, for example here, the end of the answer all false. All false, the situation, the statement we call contradiction. Here, contradiction or absurdity. So tautology is a statement that all always true and possible or for all propositional variables. Contradiction always false for all statement. Contingency, it can be true or false depend on the true value for the proposition statement. So please remember, if the last answer for this statement as if all true, so this statement we will declare as contingency. If all false, we declare as contradiction. If false true, we call contingency. Okay, so please remember this term and the definition, because in test or in final exam, maybe the question will be answered. Once you have the complete truth table, the question will ask, is that the statement, what is the situation of that statement, tautology, contradiction or contingency? Look on the last part or last rule. Okay. So then if P if and only P is tautology. If tautology, see, if the tautology, we can say that yes, this is the statement is equivalent. So once we get this is tautology, this means all true. So we can declare the whole statement of S is equivalent. Equivalence. So in order to get the statement is equivalent, make sure that the last answer all true. It means once it's true and we declare as tautology, then we can say that statement is equivalent. Like this one. P equivalent to Q. So in order to get the statement equivalent, we need to test is that tautology or not. In order to find that one is tautology or not, we need to find the whole condition all true. Then we can call equivalent. Okay, for example, given to you, show that these two statements are equivalent. So we put like this one, are equivalent. So how to solve it? We need to get the answer for this one, means the truth table situation for this one and this one. P or Q? Q or P? Is that equivalent? We look. Here, standard PQ, true, false, true, false. Then P or Q. So we get true, false. Q or P, we get true, false. Now we compare these two columns. Is that have the same value? Here true, yes, true. Here false, here true, yes, true. Here true, yes, true. Here false, yes, true. So once we get all this true, so we call tautology. Once it's tautology, it means equivalent. That's the idea of equivalent. In order to declare that statement is equivalent, we need to check is that tautology or not. In order to check that one is tautology or not, we need to get all true for all condition happen. Then we can declare that one is equivalent or not. Again, given to you two statements, this statement and this statement. Is that equivalent? Is that we can say equivalent to this statement, to this statement, this statement to this statement. So we check. If P then Q, we get this. True, false, true. Then to handle this here, we need to deal with not P first. So we get the column for not P. So not P, we focus on P, true, false, here false, true. Then once we have this one, then we compare this one or with Q. So not this false or true, false, compare true, false, true, false, true. So once we have this column, and previously we already get this column, so we compare this value and this value, because here need to compare with here. So true, okay, true, false, true, true. So all true. So we can call that this one is tautology. Okay, based on that kind of situation, theorem 1 has been produced. So this is the theorem behind that situation. If P then Q, the equivalent to if Q then P. If P and Q and equivalent to P and Q and P and so on. This is theorem. So all this theorem. So the important thing, you know, all the compound statement and conditional statement with the logical operation involved. So that's it for today.